So students, previously we have discussed about the trends in the ionization enthalpy, and ionization enthalpy is basically the energy required to remove an electron from the isolated gaseous atom. Now let us move to our next term, that is electron affinity, or we can say that electron gain enthalpy. So our next term will be electron affinity. And what will be the another name for this electron affinity? It is also termed as electron gain enthalpy. It is known as electron gain enthalpy. Now, as the name indicates, this is the amount of energy, because as the enthalpy is mentioned here. Now, this energy is the amount of energy required to add an electron in the neutral atom to form an ion, because when the electron is added, an ion is going to form. So, this energy is not an energy required to remove. It is basically an energy that is needed to add an electron to form the anion, and it is again calculated in kilojoule per mole. So, let's consider here firstly definition here. It is defined as a energy. It is defined as a energy required to add an electron in a neutral atom to form an ion. It means an ion is formed and energy is basically added to add an electron. So let's have a general look at this kind of the energies. Suppose I have a metal M. Now in this metal we have to add one electron. If I am adding this electron, what I am getting here? I am getting this anion here, and energy is added. So we can see that this energy will be added as electron affinity or electron gain enthalpy. So this will be the general description of such kind of the metal. Now you can see that if we are needed to add a one more electron, if I am going to add one more electron, that one more electron will be going to added in the such kind of the compounds. So in M negative, I am again adding one more electron. So if I am adding one more electron here, these two processes will need a different kind of the energy. So this will be electron enthalpy 1 and another will be the electron gain enthalpy 2. So we can say that, suppose I am writing here O plus electron, O negative. This is our enthalpy number 1. If I am needed one more electron, if I am adding one more electron, what I am getting here? I am getting here O2 negative plus EA2. It means 2 electron has been added here. So in both the processes, you can see that different amount of energy is needed, but in this case, the amount of energy, that is electron affinity, in the first case will be exothermic and in the second case it will be endothermic. So you have usually heard about the term that is exothermic and endothermic. Exothermic is a process in which the heat is evolved, and endothermic is a process in which heat is usually taken. This is exothermic process or this is endothermic process or the reaction. Now let us consider the example of chlorine here. We are taking an example of chlorine here. Now in case of the chlorine, we can see that in the Cl ion, if I am adding one electron, I am adding one electron to the chlorine atom. So what I am getting here? I am getting here Cl minus, and I have needed an energy to aid the electron, and this energy is 349 kilojoule per mole. So we can see that amount of energy is added to add an electron. Now we can say that the unit used to express the electron affinity is again kilojoule per mole. unit of electron affinity is again kilojoule per mole. So this is all about the basics of the electron affinity. Now what we have to observe, we have to determine or we have to get the knowledge about the trends in the periodic table about the electron gain enthalpy. So let us move to our next topic, that what are the trends in the electron enthalpy. So the next topic is trends in electron affinity in periodic table. So what will be the trends in the periodic table regarding electron affinity? Firstly, we will consider it along the period. First is along the period, and the second case we are going to consider is along the group. And the second case we will consider here is along the group. Now let us move to discuss about the variations in the enthalpy along the period and along the group. So firstly, electron affinity. It means energy required to add an electron along the period, it is going to be increased. Why it is increasing along the period? Because along the period the effective nuclear charge increases and atomic radius is going to be decreased. So in case electron affinity is going to increase along the period because effective nuclear charge increase and atomic radii is decreasing. Atomic radii is decreasing. If I am considering along the group, it means if I am going from top to bottom, what will happen here? The electron affinity or the electron gain enthalpy is going to be decreased. Why it is decreasing? Because the effective nuclear charge will be less. Because the nuclear charge decreases and atomic radii is increasing. So what will be the effect of nuclear charge on the electron affinity? You can see from here, as the effective nuclear charge decreases, it means the effect of the nucleus, it means the force of attraction of the nucleus is very less on the outermost electron. It means it is not going to attract the electron cloud towards itself. So if it is not doing so, it will reduce the value of electron affinity from top to bottom. It means along the group. So this is the trend in electron affinity we have seen here. From this electron affinity, we have derived some more characteristics. So let's discuss these characteristics here. So these are the trends in the metallic or the non-metallic character we have seen. But if I am talking about the reducing nature, so as we move from top to bottom, as we are moving from top to bottom, we can see that the reducing character is going to be increased. And if we are moving from left to right, it is going to be decreases because we are considering reducing nature here. The oxidizing nature will be opposite to that of the reducing nature. As we are moving from left to right, it will increase and oxidizing nature will decrease in moving from top to bottom. So this is how metallic, non-metallic and the oxidizing and the reducing nature will going to show the trend. So electron affinity topic is over here. We will deal with many more topics in our next lecture.